Okay, so this week we begin the cardiovascular system. We are actually going to have a two-part unit. So the unit will be broken up into 2 weeks. This first week we'll focus on the blood and heart, and then next week we will focus on the blood vessels, and we'll include the lymphatic system and talk about immunity in that as well. So just to start off with blood, we have some objectives I want to make sure we cover. We're going to look at how blood is composed. We want to make sure we understand the components of blood and what leads to their formation. And then we'll make sure we understand steps in hemostasis, which is what happens when you get injured, and then understand different blood groups. So different functions of blood, transportation, so nutrient delivery, oxygen, other nutrients that the cells that are spending energy all day need, such as calcium, different ions, sodium, glucose for sugar, and then also got to remove wastes like CO2 and different byproducts of cellular activity from those tissues. So blood helps get nutrients to them and take the tissues or the wastes away from the tissues. And then functions of blood also include defense, and so it'll have white blood cells in there helping seek and destroy invading pathogens. And then also in blood clotting, we want to make sure that we can not bleed out when we get a cut, and so one of the defense mechanisms is to help clot that blood. And then maintenance of homeostasis, we have two aspects of that. So thermal regulation, ensuring the temperature of the body is regulated, as well as a chemical balance with making sure the water content in the body is balanced, and also the pH. So those are the general functions of the blood. Properties of the blood, so like we discussed in our tissues lecture, it is a connective tissue. It is actually approximately 8% of your total body weight. It's a little alkaline, so it's like a 7.35 to 7.45, typically in that range. Anything above that is an issue, and anything below that is also an issue. And the color of your blood is scarlet if it's rich in oxygen, or darker red when it's not so rich in oxygen. It's never actually blue. The reason that your veins look blue is because those wavelengths are bouncing off of the skin and being making their way to your eye, whereas the rest of those wavelengths are being absorbed. So that's why it looks blue, but it's not actually blue. So looking at some of the composition of blood, you can see that blood itself is 8% of the body's volume, and 92% of the rest of the body is everything else. So obviously, so 8% of the blood, or of the body, is blood. And then that blood is made of 55% plasma, which is the liquid component of blood, and then 45% of formed elements. These are solid matter or cells that make up blood itself. And so we're looking at plasma. It's mostly water, about 92% water. A bunch of proteins, so albumins make up the largest chunk of the proteins in plasma, but then globulins and fibrinogen. We'll talk about those in a little bit. And then other solutes, so all the different ions and waste products, nutrients like glucose, and gases, oxygen, oxygen, carbon dioxide. Mostly oxygen is going to end up being carried by the red blood cells, and then looking all the way back at the formed elements here, it's mostly red blood cells, but there's also some white blood cells and platelets in there as well. And those white blood cells consist of different types of cells, and we will talk about those a little bit as well. But mostly the formed elements are red blood cells. So what makes up blood? Like we were just talking about, this just breaks it down a little bit more clean. 55% plasma, 45% formed elements. Most of those are red blood cells, 44%, and then 1% are white blood cells and platelets, and that's this buffy coat here. So it's a very small layer. And the blood percentages do change whether you're female or male. I'm not super concerned with you memorizing this by any means, but it's just interesting to know men have a higher red blood cell count than women do. Now plasma, Well, most plasma proteins are going to be produced in the liver. 92% of plasma is water, and 7% is protein. And this 7% is made of albumin, globulins, and fibrinogens. So the albumins regulate your water concentration between the tissues in the blood. Globulins are going to be, think of glob and like protein clot or blood clotting. They're going to be functioning with antibodies in the immune response, and then blood clotting in that aspect as well. And then fibrinogens are involved in that blood clotting process too. We'll talk about them when we get to hemostasis. And then 1% of blood plasma is everything else: hormones, proteins, nutrients, ions, and wastes. But yeah, that's the gist of plasma. Not too much to know here, just kind of understand the different percentages. It's mostly water, but then there's a little bit of protein in there. Formed elements, so this is your blood cells and platelets. So you got red blood cells, your erythrocytes, function to transport oxygen and carbon dioxide. Your white blood cells, your leukocytes. You have granulocytes and then agranulocytes. In the the granulocytes, you have neutrophils, eosinophils, and basophils. And then agranulocytes will have the lymphocytes involved in immunity, and monocytes. These are macrophages, but we'll talk about those in a bit. And then you have platelets, your thrombocytes. Think of thrombo as meaning like clotting, and so they're clot cells. So like someone with the thromboses is like a blood clot or like an embolism. But yeah, so these are the solid components of blood. Your formed elements are solid components of blood. And only the leukocytes, the white blood cells, have nuclei, and all the other organelles. Red blood cells emit their nuclei so that they can make more room for carrying oxygen. And platelets are just fragments of other cells. And we'll talk about that a little bit more in detail later. So red blood cells, their structure is biconcave, and they're like little discs. And this promotes a large surface area for gas exchange. So a sphere itself would have less surface area. And this little divot increases that surface area for oxygen to kind of hang out. And so there's no nucleus, they emit it, they are anucleate, in mature red blood cells at least, ones that are carrying oxygen. They're made of approximately 95% hemoglobin as a protein, so it's mostly just carrying oxygen, and this is what contributes to the red color. And structural proteins, lipids, ATP, carbonic anhydrase make up the rest of red blood cells. Don't worry too much about memorizing that, just understand that it's mostly hemoglobin so that it can carry oxygen. So transport and exchange O2 and CO2. So hemoglobin now consists of 4 globin molecules, and those transport carbon dioxide, and then 4 heme molecules. And so the hemes are these dudes, these little discs, and then the globins are the outside ones, and they carry carbon dioxide, whereas these little hemes will carry the oxygen. And then iron is in the middle. Can't really see it here, but if you look at a molecular structure, it's held together in the middle, and this is required for the oxygen transport. And so if someone is low in iron, there's less oxygen being able to be bound to this hemoglobin molecule, which makes up most of red blood cells, which means less oxygen is going to be getting to the tissues that need it, making that individual feel tired and weak. But in a normal person, each hemoglobin molecule can carry 4 oxygen molecules, and then each red blood cell has 250 million hemoglobin molecules on it. And so that means that, multiply 250 million by 4, you get 1 billion oxygen molecules per red blood cell being carried. So lots of oxygen on one red blood cell. Evolved that way so that it can carry just oxygen. It's just its only function is just to carry oxygen and carbon dioxide. So how are formed elements created? So this process is called hematopoiesis or hemopoiesis. You'll see it either way. It's the production of blood cells, white blood cells and red blood cells. and it increases in a state of what's called hypoxia. So think of hypo as meaning too little, and oxic meaning basically oxygen. So it's too little oxygen, low oxygen levels. So all formed elements are going to arise from stem cells, and I guess I didn't really mention this. I want to make sure I mention this. Different things can cause hypoxia, such as, obviously like a disease state with like lungs not functioning as well, or someone with mutated hemoglobin somehow. Exercise is going to make it to where you're breathing a lot faster and you're expelling a lot of oxygen in that cellular respiration. Altitude is going to be a little bit thinner air, so it's hard to acquire as much oxygen, so there ends up being a little bit less oxygen in your body. And so all these things will increase hematopoiesis. But stem cells are generated in red bone marrow. They are unspecialized, meaning that they can turn into different cells and become specialized, so that those cells go on to do a function that is special, such as become a bone cell or become a brain cell or become a blood cell. And so differentiated cells go on to do their own task, special task. So they differentiate into specialized cells when they're stimulated by various growth factors. So erythropoietin, EPO, stimulates red blood cell production. And so you can see here we have our stem cell. It divides, becomes a myeloid stem cell, and it has a bunch of different things that it can divide into. And there are hormones coming in and influencing the division of where these are going to end up. And so hormones are pushing them toward a certain state. And so erythropoietin just so happens to push the stem cells toward becoming an erythrocyte or red blood cell. And a thrombopoietin would be pushing the cell to become a platelet. All right, so we'll get to that in a little bit, but just understand that stem cells are undifferentiated, unspecialized, and they differentiate to become certain cells, and erythrocytes are stimulated from the erythropoietin influencing stem cells to differentiate into them.